So in this video we are going to use the A* algorithm to move our monsters, and this means that we will be able to spawn some monsters in the game by clicking the next wave button, and these monsters will move from the starting portal up here all the way down to our end portal down here, and it will of course move around all the objects like towers and such because we already created the A* algorithm. Right now we can click on the game grid here and create some debugging information, but now we have tested our A* algorithm and we are sure that it works well. Then we will have to comment out some functionality. For example, inside our A* script we have this line of code that will debug the path, and we will actually have to comment that one out because we don't need it anymore. Just keep it there so that you have it for later if you need it later to do some debugging. Besides that, we also have our A* debugger script, and in updating that script we have a click tile function and a space click, and we can basically just comment out the whole update function here because we don't need that anymore either. We will comment it in again if we need it later, but now we will have to generate a path, feed the path to a mob, and then let the monster run through the level by using that path. So to do this, we will have to generate a path inside the level manager because we will be spawning a lot of monsters in the game, and there's no reason for us to generate a new path every time we spawn a monster, because I will have it so that we have a cooldown in between rounds, and in between rounds we are able to build towers, and when the round is going on we are not able to build towers. And this means that only when we click the next wave button, when we click that button, we will have to generate a new path, and no other point we will have to generate that path, because we will only have to generate it once when we click the button, because then 10 monsters spawn and they can all use the same path, because there's no way we can place a tower when the wave is going on, so there's no reason to generate new paths all the time. Yeah. So let's see, what should we do? We need to generate a path. So let's start with going to the level manager, and then we need to create a path in here. So first of all, we'll have to create a private stack with nodes, and this is going to be our final path. So this variable right here, this stack right here, is going to be the final path, so we can give that to all our monsters so that they can use it actually. Besides that, we will also have to create a function, and this function is called generate path. So down here in the bottom we can make a public void called generate path, and this function will generate a new path for us. So it's going to be final path equals A* dot get path. Starting point is our blue spawn, and our goal is our red spawn. And remember, if we go up here, we'll see we have a red spawn and a blue spawn, and these are the points where our blue portal is spawning and the red portal is spawning. So because of that, we can use those 2 points to generate our path down here. So right now it's complaining, and it says that we cannot convert void to system collection generic stack. That's because our get path function doesn't return a stack. So we need to go to the A*, and right now it returns void, which means it doesn't return anything. So we need to make sure that this function returns a stack of nodes. When we have done that, we will need to go all the way down here, and then we have to return final path. So now we're returning the final path after our A* is done and we have found the path. Well, then we return it. So because we're returning it, we can grab it out here in our level manager and use it. So now we have a reference to the final path when generate path has been called. The next thing we have to do is to execute this function here, and we can execute it 2 places just to make sure that we don't have any errors. So basically, when we spawn or when we click the spawn wave function, then we should generate a path because I clicked the button and then the path should be generated, right? So let's just search for spawn wave, and we have a start wave function that's called spawn wave here. And in here, inside the game manager, we can actually call level manager dot instance dot generate path. So this is executed when I click the spawn wave button, which means that we will generate a path when we click the spawn button, and that's it, because we only need to generate this path once, as I explained earlier. So when we have this path here, we can actually use it for something in our monster. But just to make sure that we never return a that we never get a empty path for our monsters, no matter what, then we can actually make a property. This property will also serve another purpose, because right now we are using a stack, right? And we are going to return this stack to our monsters. To make sure that our monsters doesn't get the stack and start popping the stack and changing it, we will have to return a new stack. Because imagine that we play our game, we generate our path, and we give the final path to the first monster. The first monster will start popping this stack of nodes, which is the final path. So it takes and removes a node from this path every time it moves to a new node. And this means that the next monster that starts using the path will have a path with missing nodes in the beginning, right? So it will walk a different way, because maybe the first monster managed to pop 2 nodes from the stack, and the next monster that spawns will have 2 less nodes. So we will have to make sure that we create a new stack and return a new stack to each and every monster, right? So we can make a public stack node called final path with capital F. Or actually, I would like to call it path. I'm also going to rename this one to path, actually. It makes more sense. Final is more like something we have in our algorithm. Anyway, I'm going to write get, because I need to return this path to every single monster. First of all, it's very important that the path isn't null, that it exists before we feed it to a monster, right? So we need to make an if statement that checks if our path is null. So if the path is null, then we are going to generate path here. So when we have checked if it's null and generated the path, well, then we will have to return new stack of nodes, and we need to create a stack of node that actually contains a lot of nodes already. And to do this, we will have to feed it like new stack node full path. What's called path, that's what it was called. There we go. So we give it a stack of node that contains a stack of nodes with the path in it. So basically this line of code creates a new stack of nodes so that each monster has its own stack of nodes that it can use to walk through the game world. And this is needed so that we don't use the same stack and some monsters pop the stack and another monster don't get to use the whole path and so on. So this is basically why we are returning it in this odd way here. Yeah. Okay, so now we can get the path on a monster. We will have to use this path on one of our monsters now. And to do that, we will have to open up our monster script. And there's a few things we have to add because our monster is missing quite some things. First of all, we need to make a private float called speed, because our monster needs to move now, right? And we would like to give it a speed, and we are going to serialize this field here. So we are going to set the speed from our prefabs, because maybe some monsters need another speed than others. And later we will also have to make this speed into a property, or make a property for this speed, because, for example, the slowing tower will affect the monster speed, and it will have to access the monster speed and reduce it at some point, but we will get to that later. Okay, each monster needs its own path, so make a private stack of nodes called path. And this path needs to be equal to the path we just generated in our level manager, right? So we will grab that and set this path equal to that later. We don't have stack here because we need to go using system.collection.generic here. Now we can use our stack. What else? Our monsters need some positions. We need a property, and it's going to be a point. and we're going to call this one grid position. This is the monster's grid position. We will need that for the A-star algorithm later. And what else? We will have to make a private vector free called destination. Could also be a vector 2 actually, I think. So we have our grid position and our destination. So now we know where to move and where we are, right? So this grid position is where we are at the moment. This is where we're going to go in the actual world as a vector 3 position. So we know where to physically move the monster. Yeah. I think that's it for now. Then we will have to write an update function. So let's make an update. Private void update. And this update is going to call another function. So we're going to create the function that update needs, and we are going to create a move function because now our monster would need to move. So let's make let's make that below here, called private void move. And the move function will move the monster. Just to make sure that we call this one, we will go to update and we will execute move right away, so that we don't forget to execute it. And one thing is also important, we will have to set the speed from the inspector. So remember to do that before you click the next wave button. If you don't do that, then your monster is not going to move, and then it's not going to work. Okay, so the move function. We will have to make sure that the monster moves from tile to tile, from node to node, right? So to do that, we say transform.position is equal to vector 2 dot move towards. So vector 2 that move towards can be used for moving towards a target, and to do that we will need to tell it where it is right now, and it is on the transform.position. So this is its current position. Then we will need to tell it where it needs to move. Well, it needs to move towards its destination, which is the one we are creating up here, and I think I could do it into a vector 2 actually without any problems. Let's see. And then we will need a speed or some distance, how much it should move every frame here. And this is just going to be speed multiplied by time dot delta time. There we go. So this line of code will make our monster move, but we haven't set its destination yet. So for this function here to work, we will have to set the destination somehow. And we will actually do that in another function in a second, so don't worry about that. So the next thing we'll have to do is to make sure that we don't move, or we change our destination when we have reached our destination, right? So we say if our transform.position is equal to destination. So if we have hit our destination, and that's exactly why we are using vector 3. So we are going to change this one to a vector 3 again. And then you shouldn't have a problem here. It's because if destination is a vector 3, then it can't compare it to our position, of course. So that's why I made it into a vector 3. So if our transform the position is equal to destination, so if we are at our destination, let's say we start at our goal. Not our goal, sorry. We start at our starting point. Right here at this portal up here, and we want to move down here. Then at some point we will be hitting this tile here, and when we are in the center of this tile, our transform the position is equal to the destination, and each tile here is a destination. So we will change our destination every time we hit a tile, and that way we are going to move from through the path, right? Because let's say we need to move from here to down here, then it's going to transform, then it hits the destination here, it's going to pop the stack, move down here, pop the stack, move down here, and so on. So that's why we need to move to our destination. So destination is not our goal, our final goal, it's just the next tile we need to move to. Okay. So if that's the case, then we say if our path isn't null, just to avoid errors, and our path.count is larger than 0. So if our path count is larger than 0, then we still have some way to travel, right? Because there is still something in our path that we need to move towards. Then we say grid position is equal to path.peak.grid position. Remember, if we peek, we do not remove it from the path, from the stack. We only look at it. So we are going to look at it and take the grid position and store it in our grid position. And the reason that we're storing the grid position is because we need it later. But I'm already preparing the project for this so that we can use it later when we need it. And here comes the important part. Destination is equal to path.pop. So we remove the tile from the path dot world position. So we don't have a world position on our node, so we will need to create that so we know where to move, because we need a world position in each node so that so we can use the transform the position to move towards it in the actual game world. So we need to open our node, and then we need to make a let's see what I've written. I've written that we should make a vector2, so make a property vector2 and call it world position here. And when we have created that, we can go back to our monster and say pop and then get the world position here. Okay, so this is not going to work right now because our node never sets its world position, right? We are only setting the grid position on the node. So we will have to say this dot world position equals tileref dot world position. There we go. So now we have a world position on the tile, so we know where to go on the grid, on the node, and we have a grid position so we can use it later. But right now our monster doesn't have a position right away when it spawns, so we'll make sure that we actually assign a position to the monster when it spawns. And to do that we can make a function, private void, called set path. So this path function here will be executed when we spawn the monster, so it actually gets a destination right away. First of all, it needs a path, so we need to say stack node new path, and yeah, that's it for now. That's it. Then we say if our new path isn't null. So if new path we give in here isn't null, well, then we have something to work with and we have something that we can use to move our character with. So we say this.path equals new path. So now our path is set. Then we say grid position equals path.peak grid position, and we say world position, what's called destination, sorry, that's what it was called, destination equals path.peak world position, and it shouldn't be peak, actually it should be pop. There we go. So again, we do exactly the same thing. We set the grid position and the destination, and the reason that we're creating this function is because we need to be able to execute this from our spawn function. So we're just going to divide the responsibility into different functions. So I made a set path function here. And where do we need to call it? Well, we need to call it inside our spawn function. So if we go up here and see we have a spawn function here, when we have scaled and everything, we will need to say set path, just to make sure it has a path, level manager dot instance path. There we go. So now we are setting our path on our monster when we spawn it. So let's actually try to save this. I know it was a lot of code without testing, but it's kind of hard to test these small things because there are so many things that needs to be put together to make something work, right? So let's try to run it. And I click next wave, spawn our monster, and nothing happens. And remember what I said, remember to set the speed on your monsters, else they're not going to walk. So go to prefabs, go to monsters, and select all your monsters, and see the speed here and set it to maybe 1. You can always change this yourself. I'm just going to go with 1 here. Okay, let's try again. Play the game. Next, and then you see the monster spawns, and he starts moving very early, as you can see here. If I maximize, you'll see he starts moving before he's done scaling, right? So it needs he scales from, it looks like he scales from the corner of the tile instead. So we will actually have to fix this. And it's a very easy fix, and it's also something we are going to use for our object pool anyway. So let's try to fix this. The fix is very, very simple. We need to go to our monster script and make a new property. And this property is going to be called, it's a bool, sorry. And we call it isActive. So isActive is going to decide if the monster is moving or not, right? So right away, we are going to make sure that it only does this if it's active. So let's just go to our move function here. And inside move, we make an if statement that says if isActive. Then we move all the code here into the isActive if statement there. So now it's only going to move when it's active. But we need to make sure that it isn't active from the get-go, right? So basically, we should set it inactive from the start, and then set it to active when we are done scaling, right? So let's do that. Let's go to our scale function, and here we're done scaling right here on this line of code, right? So we can actually say isActive true. So here we are setting it active to true, because we are calling scale, we are setting progress 0 and everything, scaling it up and everything. And when we're done scaling, we make sure that it has the right size, and then we make sure that the monster is active so that it can move. When we start scaling, we will also like to set it to inactive, so we say isActive equals false. Go. So now we set it to active false. We make sure that we scale it, and then we set active to true. So let's try to save this, and let's try to play the game again. Click next wave, he spawns and starts moving when it is done scaling. I know it's a little hard to see from that 100 we have up there. Maybe you want to move your portal, move the 100 away, but we can actually spawn our monsters. So another thing, we will have to spawn some towers here, so we can try to see how it looks. But there's one little error here. You can see I'm not able to place a tower up here in the top one. And the reason that I'm not able to place a tower here is because my number up here, my value up there, is actually blocking my path, right? So I need to do something so that I can actually place a tower up here, so that the money doesn't block it. It's a very easy fix. If you click the money up here, the currency text, and you click add and write canvas group, then you can see on a canvas group there's something called block raycasts, and we're not interested in doing that. So you can actually remove block raycast from this, and then you should be able to place a tower up there as well. As you can see, now I can place the tower up there. And you can try to make some kind of maze for your monsters here. Try to see if everything works as it should. If they walk the right direction and everything. Click next wave, you see spawn monster, it starts moving. And it moves down here and moves there and everything. So this looks like it actually works. It doesn't cut corners and anything when there's towers. And it walks the correct way towards the red portal here. Just going to do like this so you can actually see something. Yeah. Anyway, it is going to move from this destination to the red portal here behind my webcam. Anyway, you can play around with it yourself. So that is what we're going to do in this video. As you can see, the monsters are not animated, so we're going to do that later. Make sure that they're animated and they walk the right direction with the animation and so on, of course. But this is just the start for using that A* algorithm. So I hope that the game is starting to look a little more like a real game, as you can see, and will also add damage and so on, of course. So thank you very much for watching, and remember that Inscope Studios is a community founded page, so all your support is very important to me. You can support me in different ways. Support me on Patreon by clicking the top link, or you can support me by getting one of my projects as a standalone product. Also, don't forget to follow me on Twitter, like my Facebook page, and subscribe to the channel. And also, if you like my tutorials, do not hesitate to share them. That really helps me out a lot if you share my tutorials with your friends or your classmates or whatever. So thank you very much for watching.